Hello. In this video, we're going to see how to validate the implementation of a Wi-Fi offload solution for an LTE network. Or in other words, how to guarantee the correct handoff between LTE network and a Wi-Fi offloading subsystem. It should be remembered that one of the primary goals of Wi-Fi offloading is precisely to move heavy-duty services out of an already congested cellular network towards a Wi-Fi access point in which speeds and densities are more easily managed. Several topologies of the network need to be tested, verified, and validated to guarantee the correct behavior of all network elements involved. These topologies and tests associated are the following. First, we have what we call the LTE gateway subsystem test. In this case, the targets of the testing are the LTE gateways, since these are the elements processing the user plane that is being offloaded. And the test tool wraps around it. For it is necessary to be able to simulate UE, eNodeBs, the UE application traffic, access points, MMEs, Wi-Fi gateways, and then the option of emulating the PDN gateway. In the second test case, the target is the Wi-Fi gateway. In this case, the tester emulates the UEs, the UE applications traffic, the entire LTE network, and the Wi-Fi access point. Finally, in the third case, the system targeted is a combination of LTE and Wi-Fi gateways, providing an end-to-end testing. In this case, the tester should emulate the UEs, the applications, traffic, the internet, the Wi-Fi access points, and optionally the PDN gateway. So verifying the correctness of the Wi-Fi offload solution will require testing each one of these topologies in terms of validation and performance. Validation will consist of guaranteeing the handoff of the IP address. The UE must maintain the same IP address that was originally assigned in either the LTE network or the Wi-Fi network, and also the handling of the tunnels between the serving gateway and the PDN gateway, and the Wi-Fi gateway and the PDN gateway. These tunnels must be managed before and after the handover, meaning creation and teardown of tunnels or tunnel traffics between nodes for the UE traffic. Once this is validated, we can move to the performance test. The performance test will consist of guaranteeing the no packet loss or socket timeout during the handoffs, the no session drop as the system spikes in the number of subscribers and traffic, and with this all combined, we finalize the whole validation of the system. For the validation test, we will use a test session with a single UE and a single access point. The handoff will be configured so it will take place or be initiated 10 seconds after the UE first attaches. We will also capture a pickup trace in order to validate the call flow, meaning ensuring the persistence of the UE IP address, correct handling of tunnels, and overall success of the procedure. So now let's click Run. So as we can see, the UE has successfully attached to the network. And at this point, the network traffic is flowing. So we have the network traffic application flowing. Then 10 seconds after, we should see how there's a handoff attempt and a handoff success. At this point, it means that the UE has moved from the LTE network to the Wi-Fi offload subsystem. So now let's take a look at the pickup trace. In the pickup, we can see how the sessions are being created initially in the serving gateway and PDN gateway. The PDN gateway assigns the address 1.0.0.1 to the UE, and the Netflix traffic begins. Then, around about 10 seconds later, we can see that 10 seconds later the traffic is paused and buffered, and the emulated access point issues a DHCP discover message towards the Wi-Fi offload gateway with the option 50 activated, which indicates the request for a specific IP address. Notice how this IP address is the same one that we were given by the PDN gateway. The Wi-Fi Offload gateway receives the DHCP request and converts it into a create session request towards the PDN gateway with the PDN address allocation set to 1.0.1. At this point, the PDN gateway manages all the new channels, as we can see here, and responds to the Wi-Fi Offload gateway with a create session response with the aforementioned IP address. Here it is. The gateway then translates this response into a DHCP offer with the indication of the 1.0.1 address, as we have here. Upon acceptance of the IP, the UE then continues with the Netflix flow. And that will complete the LTE to Wi-Fi offloading. So basically, in this validation test, we validated the mobility of the IP address of the UE, how it is persistent in both networks. And we also have validated the establishment of the calls and the management of the tunnels and the transition of the data without packet losses from one network to the other. Now we can bring this setup to scale, hundreds of thousands of subscribers, to validate the performance and the offloading solution in terms of handovers per second, packet loss, and socket timeouts. For the performance test, we've increased the number of subscribers to 20,000. Those subscribers will be connecting to the LTE network at the rate of 2,000 activations per second, will be generating traffic as soon as they connect, and after 10 seconds of connection, they will perform the handover between the LTE network and the Wi-Fi offloading subsystem. This activation rate will be happening every 2,000 activations per second, and it will be on continuous handoff. And that meaning after all the UEs have moved to the Wi-Fi offload, they're going to redo the handoffs. So let's see what results we get. Again, remember this is a performance test. So what we're trying to accomplish is to make sure that we don't see any packet losses or socket timeouts, and that we maintain the rates of the gateways in the system. So in the reports tab, we see that we are already attaching our 20,000 UEs to the network, to the LTE network, at a rate of 2,000 activations per second. All activations have completed successfully, and after 10 seconds, we're still going to see the handoffs attempts. These handoffs also go at a rate at 2,000 handoffs per second, and they're successfully taking place. Once we reach the 20,000 handoffs, the system is going to wait for another 10 seconds and then redo the handovers again in a constant loop of moving UEs from one system to the other. See, now after 10 seconds, we get the activations again on the handoffs. As for the sockets, we got to verify that we don't see any packet loss or timeouts while we're still seeing information being transferred on the client and the server side.